Okay, just to continue on with this problem then. So what we've got are two awkward fractions for this displacement in the x direction. Now, because this is where the time when s of y is equal to 0, so that's equal to, well, it's the same as the range, so or is equal to that. And what we're trying to show is that these two fractions add to give this expression for range here. Okay, well, first off, what we've got is, there should be a square there. What we've got are these two expressions here, so they're fractional expressions, so we're going to have to find the common denominator in order to add them together. So, the common denominator in this case would be g cos theta. Well, actually I can cancel some things here first, so I might do that just now. I might rewrite this line, just cancelling and adding whatever we can. So generally with this, what you do is you bring all the numbers to the left hand side and leave the costs and signs. So we've got a u here and a 2u here, so that'll be 2u squared cos alpha minus theta sine alpha minus theta minus, now we've got a half here and a 4 here, a half and the 4, so that multiplied to give 2. We have a g here and a g here, g squared there, they'll cancel, so you'll be left with that's not that. Okay, now sorry about that. So we've got actually better go back to the first expression here. I forgot to put in the fraction bit there as well, so that's still all over g cos theta. So this would be 2. Now we've got a u squared, we've got a sine theta, and we've got a sine squared alpha minus theta. And this is all over g cos squared theta. Okay, so that was a simple cancelling and grouping terms. So if we go here, we're going to have to add these together. We're going to have to get the lowest common denominator for these two fractions, which in this case is the larger one, which would be g cos squared theta. Now, to change the first fraction into g cos squared theta, we'd have to multiply above and below by cos theta. So what we end up with is, draw that line there, we'll have 2u squared cos alpha minus theta sine alpha minus theta cos theta minus 2, and this, the second fraction just stays the same because of the lowest because the common denominator is shared. 2u squared sine theta sine squared alpha minus theta. Okay, let's continue that line over there, it's all in fraction. Now, if we just go back and have a quick look at what we've got here, that's a 2 there. Now, you'll see here we've got, in our final answer, we're supposed to get u squared g cos squared theta here, and you'll see that we've got a u squared there, and a g cos squared theta. So I'd probably factorize them out just to show that we're at least getting somewhere with this answer here, which will be equal to u squared over g cos squared theta times, and then the first expression will be 2 cos alpha minus theta sine alpha minus theta cos theta minus 2 sine theta sine squared alpha minus theta. Okay, that's not very clear. We'll look clear in the next line. So basically what we need to do is to get this expression here, let's put it in yellow, that expression there equal to this expression here, and we'll have our answer. So where to start? Well, you want to look into your log tables now, and you want to pick out different rules that could do something for you, or different rules that could work. Now on page 15 you'll notice that you've got 2 cos A sine B is equal to sine A plus B minus sine A minus B. Okay, and we'll definitely be using that somewhere, just so you can think about where that can be used. And yeah, so I'll just maybe show where that will be used. Also, we'll be using that 2 sine A sine B is equal to cos A minus B minus cos A plus B. So the first bit, I'm going to use this expression here. I'm going to circle the terms I'm going to take out to use that expression. Now I'm going to use this here and this formula here. Okay, so what we have is, and I can probably do this, I'll put everything in blue and then just start in red, and what's changing, u squared g cos squared theta times. Now, actually, you know what I might do is I might just fill that bit in and then substitute it in. So if I work out what it means over here, so if I have 2 cos alpha minus theta sine alpha minus theta, that is going to be equal to 2, or the sine of A plus B, which would be 2 alpha minus 2 theta, plus minus the sine of A minus B, which would be 0. So that'll just be equal to 0. So that's just going to be equal to sine 2 alpha minus 2 theta. 2 theta. That's an alpha there. Okay, now the next bit then, so that was using this rule here and that section there. Okay. The next one then I'm going to use, I'm just going to try to get a little, so I'm going to use that bit there. I'm going to use this bit here, and we're going to use this rule here. So 2 sine AB, in this case A and B are the same, so we'd have 2 sine squared alpha minus theta, that's the same as 2 sine alpha minus beta theta sine alpha minus theta. So that's our A and B, so that's equal to cos A minus B, that'll be cos of A minus B, A and B are the same, so it'll be cos of 0, minus cos of A plus B, which in this case would be, A plus B would be 2 alpha minus 2 theta. So that's equal to 1 minus cos 2 alpha minus 2 theta. Okay, problem with the pen at the moment. I'm just going to change out the battery. While I'm doing that, see if you could fill in some of the answers anyway. So the bits where it's kind of cutting out now should stop, I hope. Alpha minus theta there, that's an alpha minus theta there. Okay, so we've got that bit there. Instead of this line here, we can substitute in sine of 2 alpha minus 2 theta, and that's multiplied by cos theta. Instead of this term and this term, we can substitute in it's going to be minus brackets 1 minus cos 2 alpha minus 2 theta, bracket about that again, and there's also a sine theta there. Okay, I'll multiply this out. So we've got, I'll separate this off a little bit, u over g cos squared theta. We have sine of 2 alpha minus 2 theta cos theta minus 1 minus, bring the sine theta over that side, so you'll end up with minus sine theta plus sine theta cos 2 alpha minus 2 theta. Okay, use a different coloured pen here now. So if you notice, now we also have our sine theta from the answer. So what we have to show really is that sine 2 alpha minus 2 theta cos theta plus sine theta cos 2 alpha minus 2 theta is equal to sine 2 alpha minus theta. Now, I might just group them together. I can rewrite this. We're very nearly there now. G over G, U over G cos squared theta. And I'm going to just have them just so sine 2 alpha minus 2 theta cos theta plus sine theta cos 2 alpha minus 2 theta, and then that's minus sine theta, and that's our line. Okay, and I'll postpone that. Really sorry about this, it's not really working too well at the moment, but sure we should get this finished. So that's that line there. Now you'll notice that as well, that you have another trigonometric identity, and that is that from, let's say, which one is it there? If you look at, we have a sine A cos B, sine B cos A. That's the same as sine A plus B. And if I might just write it up in the top right hand corner here, so it's sine A plus B is equal to sine A cos B plus cos of A sine of B. Now, if you imagine that this, we could call this A and this B, that's A, that's B and A, you'll notice that that whole expression can then change. Now I'll write this in blue, just what we're not changing, u cos squared theta times, this is minus sine theta, and those two, just, if you imagine, it's going to be sine of A plus B, which would be 2 alpha minus 2 theta, plus theta, which would be equal to 2 alpha minus theta. The 2 theta and the plus theta cancel to that. And that's it. QED done. Difficult question. A lot of steps to it, but it's just a matter of looking for the right trigonometric formula to sub in. Look at the answer, constantly look over at the answer and try to find bits that you can use. And that's it. So we'll leave it at that.